Hi. All right, my name is Sarah Olson. I am a senior software engineer at the Nerdery. I'm also director of Women Who Code in the Twin Cities, and today I'm going to give you a brief introduction into iOS development. And I know that there's a lot of contention between iOS and Android, so thank you for coming to the dark side. Or the light side, probably. The Android seems more dark themed. I don't know. So the hardest part that I find when learning something new is not having the vocabulary I need to find the information. So I'm trying to search on Stack Overflow, I'm trying to search on the internet. I don't know the words to use. And when I have had mentors at work or in other spaces, they have provided me with that vocabulary. So I have this thing, I'm trying to search for it, I can't find anything. And they, go to the Google and type in the words that magically make the information appear. And over time, you learn what words to use. So my goal for today is to give you some words, and then you can take those words and learn more about iOS. There are a lot of great tutorials out there. There's a lot of information, so I'm not going to get super coding specific. We're not going to create an app today. I just want to give you an overview of kind of what the platform is like, what kind of hurdles you'll run into, how it relates to Android. So that's the goal today. The first rule of iOS development is that it's that you need a Mac. So I'm sorry, you're not going to get xcode on anything else. You need a Mac. When I started out in more of the Java space, I was a back-end Java developer for 15 years. I was heavily into database administration, XML processing, all very back-endy things, and I was really interested in mobile. So when I started at the Nerdery 4 years ago, I was like, I want to learn mobile. At the time, we had a huge demand for iOS work, so I started that first. I probably would have picked Android if I had the choice back then, but I actually really fell in love with iOS development. It's much more visual. There's a lot of aspects to it that it just kind of drew me in over Android development, so I've done both. I haven't done a heavy amount of real Android development. It's been a lot of tinkering and tutorials. I think I fixed one bug at work in Android, so that's the extent of my real-world Android development experience. But I do know the platform a little bit. I work with Android guys every day. I see their code. Apple, though, will become both your best friend and your worst enemy. It's kind of like a marriage that's kind of working, but kind of not. At first, you fall in love, and you're like, this is amazing. You're so dependent on Apple that it's great when everything works, but when it doesn't, you're stopped in your tracks. So some of the pain points are unavoidable because there's no other options. You're stuck with Apple. So it's a good and bad thing. You don't have the crazy amount of devices that you have to support that you do in Android. You don't have to support back to all these different versions and different flavors of Android. So there's good and bad there. One of the good things is the high adoption rate. So when Apple releases a new version of iOS, people switch really quickly. And they don't stick to some of the older versions for very long. Apple kind of helps this along. They're super annoying with their upgrade messages now. They stopped supporting old devices, and you kind of are stuck. I have an iPad mini 1, and I can't get iOS 10 on it, and I'm heartbroken. But that's Apple. And this is showing how quickly their OSs are adopted. It happens really quickly. So current devices that they have right now, these are all the devices that you really support. There's a few older versions that you might need to support as well, but this is what you have to test on. So there's basically, for the iPhone, 4 different screen sizes, and that's it. For iPad, you have 3, because a couple of them are doubled up. So there's really not a lot of variability compared to Android space. And here are all the devices that are currently in use. Now this is like an app developer who released his statistics because Apple doesn't really get this granular. But this is what he's seeing on his app, and it seems fairly consistent across other apps. So, you know, there are a few older devices out there, but the majority of people are on the current ones. And here's the same thing for iPad. Just so you know, here are all the current versions of Xcode, iOS, and Swift. The new versions are in beta. They will probably be released sometime in September. There are going to be 2 new versions of Swift. Swift 3 is being called the grand renaming by Apple. So there's going to be a lot of changes and very big breaking changes. So they are releasing 2.3 to kind of help with that transition period so people can still get some of the new functionality but not have to deal with the colossal renaming that's going to be going on. Swift has been changing quite a bit. We actually were developing an app during their beta last year, and it was awful because every 2 weeks they changed it again. But it's also good for advancing the language. Just don't develop on beta unless you're a real app. Play around on beta, but don't do that. So xcode is the IDE that you will mainly use for iOS development. It is free, provided by Apple. It is a huge beast of an app, and it's not super well documented how you use it. I think that was one of my biggest pain points is like, how do I actually do all this stuff in here? So it's something that just takes a lot of trial and error and figuring out, and hopefully you have a mentor that you're like, how do I do this? But it has a lot of really cool functionality in it. There's also AppCode. This is a JetBrains product. So if you've used IntelliJ or Android Studio, it will look very familiar to you. The problem with AppCode is that it doesn't have a lot of the features that Xcode has. So if you're going to be doing any design work in the app with either storyboards or nibs and zibs, which are kind of the design files that we have, it will actually open up Xcode because it doesn't have that functionality. Same with core data is the persistence within Xcode. It doesn't have that either, so that would open up in Xcode as well. For the most part, if you're doing stuff in AppCode, it's going to be more back-end processing logic kind of stuff. It does really well at refactoring and renaming things, which Xcode is not so good at. So a lot of developers will mostly work in Xcode, and then when they have to do some more refactoring stuff, we'll open up AppCode. It is not free though, so you have to purchase it. I don't remember how much it is, if it's $100 or $200. I only know a few iOS developers that actually use it, because most of the functionality you can get from Xcode. So iOS mostly subscribes to the MVC pattern. We have view controllers that are where we put most of our logic, models for persistence and database and business functionality. The views are called views. That's where we put our visual stuff. So you'll see a lot of that familiar terminology. So talking a little bit about Swift versus Objective-C. There are a lot of apps that are written in both. There are a lot of frameworks and libraries that are written in both, but most new projects now are developed in Swift. So most people have made that jump to the new programming language. Swift was created by Apple, but it is now open sourced. You can actually use both Swift and Objective-C within your app. So you can code both at the same time. If you have an old Objective-C app and you want to slowly bring it up into Swift, you can do so incrementally. So that's really great. Swift is much closer to Java than Objective-C would be, so the learning curve from going from Java will be much smaller. Swift's cleaner, it's easier to read, easier to maintain, it's safer with its use of optionals, faster. So here's just a little bit about the difference between the two. At the top is what a basic function looks like in Swift, and at the bottom is the Objective-C version. Objective-C uses pointers, so when you see the stars, that's what a pointer has to use. That was kind of a bit to wrap my head around, so we don't have to deal with that in Swift. And here's an example of a very basic view controller with just a label. So in Swift, we have this small, concise bit of code. With Objective-C, we actually have two files. We have a header file and an implementation file, so a .h and a .m. The .h is more of like the interface, defining what properties can be accessed outside of the .m file. Like if it's in the .m, you can't reach it from other classes, so it's making it public. It was kind of hard to deal with and hard to manage. There's twice as many files. So Swift is much more concise, easier to reuse, easier to maintain. I like it a lot more. So some of the features that Swift has, closures are used pretty extensively, and they're very nice. So this is basically just passing in a block of code to a function, or you can return it from a function. It's passing it around instead of only using variables. So closures in Swift are similar to C and Objective-C. At the bottom is a really great website. I'm not going to say it out loud, but it's if you're like trying to write a closure and you can't figure out the syntax because it's kind of wonky, you can go there and be like, oh, okay, that's how you do it. So it's a good website. Tuples are basically aggregating a bunch of variables within one. So what this actually ends up giving us is that we can return multiple return values from a function using a tuple. So at the top, I've defined a person which has a first name and a last name. I can actually access those through person.firstname or person.lastname. And then if I call getPersonName, I can actually return that object because it conforms to that string format. So that's pretty powerful. Optionals are amazing and horrible at the same time. It took a pretty steep learning curve to figure out exactly how to use them and not destroy your app. But it's gotten a lot better. When Swift first came out, they were changing the format a lot, so every time you get a new release, it would break everything. This was in beta. But they've finally kind of figured that out now. And it is really powerful. With Objective-C, you could pass a nil value to something and it would just like ignore it. So there was a lot of problems trying to figure out why something wasn't working because it would just be like, yeah, that's fine, whatever, when you actually expected a value somewhere. So with Swift, they're making sure, like, does this always have a value or does it not? And you have to be very careful if anything is optional that you're always, they call it unwrapping it, so that if-let statement is what they call unwrapping. I'm getting the value out of here if there is one, otherwise do something else. So generics are something you probably know from Java. Swift has that as well. So this is basically being able to pass in an object of any type and be able to perform functions on it, not knowing the explicit class. Protocols are used really heavily in both Objective-C and Swift. It's kind of like the interface for Java, like you're defining this thing must have these methods or functions. And you'll see this a lot with table views and other objects that Apple provides to you. So when you're actually using a table view, you have a table view delegate. And when things happen to that table view, it will call these delegate methods, and that's how you respond to, a user selecting a cell or other functionality like that. There was also last year, WWDC, which is Apple's developer conference, did a session on protocol-oriented programming. That was really good. So I would recommend watching that if you get into iOS development. Extensions are really fun. So this is basically like taking an existing class, like UI color is a class that Apple provides that's an implementation of a color. So we actually created a new function, or actually it's an initializer, to pass in a hex code, because we use hex codes a lot. And so we can just pass that into UI color, to get the correct color that we want. And then from there, beneath it, we have different themes. So we always want our labels to have a certain background color. So when we set the color, we can just say UI color dot label background color. And then it knows exactly which color we've picked. So basically, you can add functionality to existing classes that you don't really own through extensions. And it's pretty powerful. So more vocabulary. Screen elements. So, Android names things different. Some of the things are similar, some are not. But if you look at the screen, the very top 20 pixels is the status bar. It has your Wi-Fi signal, it has the time, it has the battery status. Beneath that is the navigation bar. Navigation bars are for navigating between screens in a hierarchical fashion. So I'm going this way or I'm going this way, but I can't jump around or do anything else. It's that kind of backward-forward motion. Beneath that is called a collection view. So we have table views and collection views in iOS. Table views are kind of the list format. Collection views are used more for images and other data that is grouped like this. The dates between those images are sections. So the collection view has sections and then cells within each section. So each image is an instance of a cell. Each of those dates is an instance of a section, and cells belong to a particular section. And at the very bottom is a tab bar. I've heard that Android is kind of having a tab bar now for the next release. But otherwise, it's been pretty much an iOS thing. It's very common in iOS, so you'll see it a lot. So talking a little bit more about navigation, most apps are broken up through tab bars and through navigation controllers. So the tab bars are used to kind of create landing pages for different areas of content. I want all this content grouped here. I want all this content grouped here. So clicking on a tab will get you to that landing page. Then from there, you would use a navigation controller to kind of navigate through that data. That's a very typical design pattern that we use. Some other navigation that you'll see is the page view controller. So you can see something that actually looks like pages and it has that curl when you're flipping through. But you can also see how that slides instead. So I see that a lot with like onboarding pages when people are giving you a walkthrough of the app's functionality. And you can see at the bottom there's like a series of dots. That's a page control that you usually see with a page controller. You'll see that on the home screen of an iOS device when you slide through the different pages of your apps. So that's what that element is. We don't have tabs in iOS. We have segmented controls. So clicking on those different buttons would show different content usually. And then there is a toolbar at the bottom. This is not a tab bar, so it's not actually for navigation. This is more like, for example, with Mail, doing actions. So you're not moving the user around, you're performing actions. So it's just important to note that that is not actually a navigational element. It's not a tab bar. It's a slightly different element. So storyboards are, for the most part, how we lay out the flow of our app. It'll tell you how screens navigate to other screens. It'll kind of show your design elements. It'll show your constraints, how your elements grow or shrink, and where they're located. Are they, connected to the top by 20 pixels, or do they have a specific height, or do they grow? All those different things are usually done in either storyboards, or you can have a nib or zib, depending on what you like to call it. That's basically one screen at a time, so it doesn't have the navigational stuff, which we call segues. So there's kind of two ways to do that. Most people have moved to storyboards now because we actually have this concept of storyboard references. So storyboard references are kind of on the right there. So I have a tab bar here. It's got a bunch of tabs, and when they click on those tabs, it opens up a new storyboard to get that functionality. So we're kind of breaking up the storyboard into more manageable chunks. And the reason this is really important is we have lots of problems with merge conflicts with storyboards. It generates XML behind the scenes. And when you have multiple developers working in the same storyboard and you're trying to figure out which thing wins and which doesn't, with storyboards it's really terrible. So we try to break things up as much as we can. Storyboard references was new last year with iOS 9. So that's why we're seeing a lot more of it now. Interface Builder is within Xcode. It's the thing that shows the storyboards or zibs and nibs. It is a kind of a drag and drop tool. So you can actually take elements, drag them onto the screen. You create constraints by dragging lines to other views or to different areas. So there's a lot of dragging. You can also add elements programmatically. So in this example, I have a view controller and I added a button to it. This is just adding the button to the view, but it's not telling it exactly where that button should go or how it should grow or any of that. So this is pretty basic functionality. And then I also added a target to it. So what happens when someone clicks that button? And it calls the test button function. So this is what a storyboard looks behind the scenes. There's lots of generated identifiers and other things. It's pretty unwieldy. So we don't really ever do anything with this besides merge conflicts. No one actually goes in here. I've never seen it, and actually edited XML to add an element to it. That would be kind of scary. So it's there. I don't think you can even see the XML within Xcode. I had to open this up in text edit. So creating connections in Interface Builder is basically, I have this label and I need to actually do something with it in the code, so I drag a line from that label in Interface Builder to my code. So it's actually physically connecting them. And I can do the same with the button function. So I have a button and I want to add what happens when that thing gets pressed. So I give it a name and then it actually adds that code with that connection in Interface Builder. So how we handle different screen sizes in here is through layout constraints. So this is something I think that Android is going to be getting soon. This took a while to really get right in Xcode, so it'll probably be a while before it's okay in Android too. But it is pretty powerful now. Once you start adding constraints, you can say, where does this thing anchor? How does it grow? Is it centered? Is it not? And once you start adding constraints, it'll tell you if there are not enough constraints to really figure out what you want to do. So right now there's a little yellow arrow next to first scene, and that's saying I've got constraints in here, but they don't quite match what I'm showing you. And then that thing would turn red if it didn't know what to do. You've got a horizontal constraint, but you don't have anything for vertical, so I can't really display this correctly. So it'll tell you when things are wonky. There are a bunch of other UI elements out there. I don't want to go through every single one of them. Apple has a document online called the Human Interface Guidelines. It actually goes through all of these and tells you exactly what's okay and what's not okay to do with it. It's very important as an iOS developer to read this document because when you actually submit your app to the App Store, they will reject you if you do not follow their guidelines. Apple is very strict, not necessarily consistently strict. Sometimes they'll reject you and you'll be like, what? And other times that same thing will go through. So it's kind of one of those things when you're doing iOS development, you have to, if you have a client, say, look, I can't guarantee you that this will be approved when it's submitted. So it could take 2 weeks for them to review it. It could get rejected. What happens if that happens? How does that affect your timeline? You have to build that into your actual timeline of work to go, okay, I need at least 2 weeks for the review process. What happens if it gets rejected? We need another week or two to fix things. So it's something to keep in mind. But reading the HIG also will give you a really good understanding of what Apple deems important, how they want you to use the elements that they've given you. So it's a good read, especially for an introduction. It'll give you a lot of the information about what are all these different elements, what are the vocabulary. It'll link to how you actually implement things if you're interested in it. So that's a good resource. Asset catalogs are how you use images and other things within your app. So you would add an image in here, and it groups each one by the 3 different sizes that Apple wants you to put in there. So we have a 1x, 2x, and 3x. And if you want to know exactly what those requirements are, you can look on the website. They're different pixel sizes and stuff. That just says, for devices with, more screen resolution, you can display the right asset. So core data is the persistence framework that comes with xcode. They have a table-based editor and a graphical editor for basically creating like a database. It can be an in-memory one, or it can be actually persisted. Core data is a little wonky to use. So a lot of people have been switching to Realm lately. But it's definitely something that a lot of apps use, and you'll probably would want to at least play around with a little while. So sharing content is a little harder in iOS. They're very strict about putting apps in sandboxes, so you really can't have that same level of connectivity that you can have on Android. So they give you some tools for doing that. One is this activity view that comes with the standard set of things that you can do. You can also create your own share extensions and action extensions. So you can say this app can actually share through this method. But if you're doing some more involved logic where you need to actually pass data to another app, or you have a website that needs to interact with your app and send data to it, you have to do that through custom URL schemes. Some common libraries and frameworks that we use, CocoaPods for dependency management. So we bring in all our libraries through there. We can set what version levels we'll accept, whether or not they upgrade, or if you stick with a particular version. Alamo Fire is a Swift library for networking stuff. We used to use AF networking when we did more Objective-C stuff. I'm not sure if they've moved to Swift or not. Realm for database and Firebase, I'm assuming you're familiar with the Android. So the other day I was at work, and our lead iOS developer said this quote: "The worst part of iOS development is dealing with Apple at the end of your project." And I was like, yes, can I quote you on Thursday? And he's like, yeah, but I'm not going to actually put his name on it. But it really, iOS development is really smooth until you get to the point where you actually want to either give someone your app or submit it to the App Store. And then we call this provisioning hell, where things are supposed to be magic and they're supposed to just work, but it all just goes to hell. So to avoid that, you can use simulators. All of the devices that are current and I think even some older ones have simulators through xcode. They all come with it. So you can do that for most of your development. If you're doing more device-specific things, like using your camera, it doesn't work in a simulator, or GPS stuff. You can get a free Apple ID, and that will allow you to actually run your app on your phone. But you have to actually plug it into your laptop and run it through xcode to do that. If you want to actually give the app to someone else, you have to have a paid developer license. It's $99 a year. And with that, you can export the IPA file, which is the file that you would use to give someone your app. You can submit to the App Store. You can submit for beta testing. So that's required for anything beyond just running on your device. And again, Apple will test your app when you submit it, and they might reject it. Test Flight is the app that they give you for submitting to the App Store. It's through iTunes Connect, so you would log in to their website online. They also have options if you want to test internally, so handing it to, I think they let you pick 16 different email addresses that you can send it to and they can download the app. External testing gives you a little bit more users. And then from there, you can actually submit your app to the App Store. They do have a review process. It's gotten a lot faster recently, but it used to take up to 2 weeks, and they might reject it. So some resources that you might want to use for learning more about iOS or Swift or other things. So Apple has a lot of documentation. It's usually pretty good. So developer.apple.swift. They also have created this Swift education course. It looks like it's geared towards teachers, but you can actually look at the content and learn it. So that's on GitHub. iOS, you can go to developer.apple.com. They have a whole bunch of stuff on there. Read the HIG. Blogs, Ray Renderlich has a lot of good iOS content, iOS Dev Weekly, NS Hipster. I found this design differences between iOS and Android link really helpful. It kind of lays out, like, here's what it looks like on Android, here's what it looks like on iOS, and what the names might be. So that kind of like, well, a button is a UI button in iOS. And then there's a bunch of podcasts. I don't actually listen to podcasts, so I asked all my coworkers like what they listen to, and that's what they gave me. And then I found that link that had some good explanation about why you might want one over the other. So check those out if you like podcasts. And that's all I have. So leaving a little early today. Is there any questions? Okay, so the question is, what if you use both the toolbar and the tab bar in the same context because they would be in the same spot and that would be wonky? I think you would probably present your toolbar within a modal, so a modal would pop up and take up the full screen, so you wouldn't see the tab bar beneath it. My guess. The other thing you could maybe do is hide the tab bar for that screen. How important is it to master auto layout? Pretty important.
Why does it give really newbies so much trouble?
When I think it's understanding how the screen content wants to move depending on the different screen size. So really thinking about what exactly you want to have happen. And with auto layout, there's just a lot of different parts and interactive, things that connecting in a bunch of different ways. So while you might get something correctly laid out, something else will be connected to it, and that will get messed up, and then it messes up everything else. So with iOS 9, they also added stack views, and I think they were trying to copy, Android had some nice kind of like layouts where, okay, we're laying out everything horizontally or vertically with this much space in between. But they're still relatively new, so there's a lot of interesting things that happen that you wouldn't expect, or trying to get around the way they're implemented. So it's not that it's really hard, it's that there's just a lot of moving pieces, I guess. Does that make sense? Okay. Yes? Yeah, okay, so the question is about how the tab bar, nav bar works if you have both of them on the screen. So the tab bar is gonna give you to get you to a landing page. So that page wouldn't necessarily have a navigation bar shown, and if it did, it wouldn't have a back button, right? So that would be like you can't go anywhere from that page except for forward. So anytime you hit the tab button, you would go to a landing page. So that's kind of the primary navigation. Then within there, the navigation bar would be your secondary back and forth thing. Yep. I think the biggest difference is that just the architecture of it is different. With Android, with the activities and fragments, things are broken up differently. So it's not like you can just do a one-to-one, like, oh, I have this in Android, I'm going to do it. In iOS, it's more like I have a screen and that screen has a controller. There are differences there, but for the most part, it's kind of this one-to-one thing. Auto layout takes a while. Starting kind of small might help, where like I don't support every single device, so I don't have to worry too much about how that content changes. I don't know, I think it's getting a lot easier with some of these more cross-platform tools like Firebase. Like if you're using that already in Android, it's a much easier transition to having that data already there. So yeah, I suppose layout is probably the biggest difference, and then just basic architecture. Mm-hmm. Yeah, I mean, just get a 6S and, like pick a device that's most common. There are a lot of things, like even in the iOS simulator, that don't work very well. For example, like maps, there's a lot of weird like artifacts and things, or it refreshes weird. So I like to have a device if I'm doing anything that's like related to maps or location or camera, which most apps have something that they're using, because otherwise you can just have a mobile website. So that's why they probably went native. I don't know. Yeah, get a device. Just get one, at least. Yeah, so Apple, for push notifications, Apple has, I think APNS is their server that they run, that you have to have the token to connect with it, and then it pushes it out. I think they're fairly similar. When we do push notification stuff at work, they seem to have the same kind of requirements that we do. I'm assuming Android probably has more functionality that those push notifications can do, just because Android typically has more kind of inter-app connectivity stuff. I don't know the like.
It's really, Android just update that data, and then
Yeah. Yeah, for iOS, you're passing, a JSON payload, and so I'm assuming it's fairly similar. Yeah. So one of the really weird things about iOS with testing, I came from the Java background, so we had unit tests and integration tests and all that. Most iOS developers I know don't really test with unit tests and stuff. So it's really hard to do because the layout is so connected with everything. Just last year, they came out with UI tests within xcode. They also have unit tests. So the unit tests have been mainly for back-end logic, but you have to try to find stuff that's nice and kind of siloed off, which is really hard in iOS, which is why they probably don't do a lot of testing. So they're trying to fix that with some of the UI testing things that have come out. It's just not quite at that point where they're really usable yet. So there's not a lot of testing going on, unfortunately. Besides QA, we love our QA people. So the question is whether Swift being open sourced has made me more interested in doing more back-end Swift stuff. Potentially. One of the reasons I really liked mobile development was that I could create something all on my own, and for many, many years, I was just one small piece in a big puzzle. So that's why I really like being able to do layouts and backend and database and everything. I've got it all in one big package. So I don't know if I would be interested enough in something that's just backend again. But I think it'll be really interesting to see what starts happening with Swift. I know that it's one of like the more wanted languages to learn, and people are really interested. So I'm hoping that a lot more Swifty stuff comes out. Yeah. Anybody else? All right, thank you.